Hey and welcome. Today I will show you how to solve reverse a linked list problem. This question has been mostly asked by Amazon, but it also asked by other companies like Apple, Microsoft, Uber, and a few others like so. We will use JavaScript and explore a recursive solution. This is the follow-up video for previous implementation where we reverse linked lists iteratively, so make sure to check that one first. Link in the description below. So without further ado, let's dive in. Okay, let's go through the problem first, like previous one. Given the head of a singly linked list, reverse the list and return the reversed list. Let's see some examples. Here are examples. Since question and examples are like the previous one, we will pass this step quickly, just in case to onboard you first with what this question asks. In first example, we have nodes from 1 to 5 as a linked list, and in below, we have the reverse version of the same, starting from node 5 and ends at node 1. Second example is the same, but minimal version. And last one is an empty linked list, and we return an empty one as result. We covered iterative solution in previous video on the channel. I'll put the link for it in the description, so make sure to check that one as well. But how we should iterate recursively through a linked list? In any recursive call, basically there exist two things. First is check for the base case of recursion. It means where we need to stop. Second is so simple, calling the function itself again and again, meanwhile doing something if you want, until we reach into our base. But let's look into those two in our linked list. Here's our simple linked list. First is the base case. What do you think could be the very bottom line for us that if we need to divide our linked list into smaller portions, it would say us it is enough and we don't need to do it anymore. I mean, if we look closely into our linked list, we could actually divide it into smaller portions in order to do some work for each portion. In our case, switching the pointer and then get into the next portion, do the same thing again. What would be the stop case for us? This null node at here, right? This null node indicates that we are at the end of our linked list. So in order to reverse our linked list with recursive strategy, we need to get as deep as we can to reach to our null node or base case at the end of our linked list and mark the node before that as our new head on the way back from call stack. We will pick nodes one by one to point to the correct previous node in the sequence. So at first recursive call, we are at here at node 1. We will check for our base case first. Are we in node null? No. Do we have any next value to go? Yes. So we will invoke our recursive call and pass our next node as head into that. Moving on to the next. Now, one important thing happened with our recursive call. We are still not done with our first initial function call. We are still inside of that blue box and we will get back to that soon. So we'll move us from blue box into cyan box. Again, two questions. Are we at null node? No. Do we have something next to move? Yes. Then call our recursive function while passing next node as head to it. Remember that we are traversing in linked list and that next pointer is the only clue we have about where to go. Moving on, we are not in null node and we have something as next node. Let's call it again. One more time, we are not in null node. We still have something as next node. And finally, we are not in null node, but we don't have anything as next node. Finally, our break case. We reached into a very ground level of our recursion and found our base case. At this step, since we are at the end of our linked list, what we need to do is somehow marking our current node of 5 as the new head. In the other hand, we are deep inside of our call stack of recursive function calls. We need to go back to the very first function call in this call stack sequence and at the same time make nodes in each step one by one to point to each other in backward. Firstly, we need to start with the new head that we just marked, node number 5. If we return our last node of linked list in base case, it would literally mean moving back one step in the call stack here. Now things will going to be very interesting in the way back. The action for finding our last value will be returning it backward. That means now we are in node 4 and its call stack, but still having our new head of 5 pointing to null. So we need to do two things here. Node 5 should not point to null because it is our new head and linked list starts from that node. So it should point back to 4. Node 4 on the other hand still points to 5. But remember that when linked list ends, you are absolutely right, when it points to null. So we also need to change 4 to point to null because our reverse linked list currently ends at node 4. How we are going to do that? This is a bit confusing, but first we are going to rotate 580 degrees backwards. So node.next, which points to null, discard it, and then point back to the current node, like that. Now, next step for us, if node 5 is the brand new head, and if it points to node 4, then 4 should act as a temporary last node of reversed linked list. So it will be pointing to null. Now let's do it one more time. First, we will automatically go back in our call stack since we are returning in our recursion calls. So we land in call stack of node 3. Still being aware that our new reverse linked list starts from node 5. Now our current node, aka head node, is 3. It points to 4, but we want our fourth node to point back to 3, and then 3 points to null. So our head node is 3 in the call stack. 3's next is 4, currently pointing to null. We want to change that. Instead of pointing to null, it points back to 3, or current head node. That was the process. Head.next, assign back to head again. Then last step in the call stack would be 3 should point to null, since it is the last item in our reverse linked list for now. Moving on to the next call stack, node 2. Yet we know that 5 is our new head. So our head is 2, 2's next is 3, currently pointing to null. We want to change it. Instead of null, it points back to 2, or current head node. So one more time, head.next, assign back to head again. Then the last step would be 2 should point to null. Let's repeat this cycle one last time for the last node in the call stack. Still 5 is head. Again, our current node is 1. It points to 2, then 2 points to null. We will discard it, and instead of null, we will change it to point back to 1, or current head node. Again, for one last time, head.next should be assigned back to head again. As usual, since this is the last call stack, our head node should point to null again in order to indicate the end of our newly reversed linked list. In this step, we are in last call stack, still carrying the head node from our base case up until now with ourselves by returning it in each recursion. Now we can simply return that head node, which is going to be the entry point, and look what we have in our hand, a reversed linked list. Pretty much complex workflow here, but code is just a few lines. So let's jump into the code now. Here we are in Leetcode. First thing is going to be our base case. We will check for if we are in the node that points to null. In other words, if we are at the end of our linked list. So we will do if head.next points to null or equals to null, return the head itself. Then after we assure that we have something to chase, we will do our recursive call, reverse list with head.next. But since we return our head node from our base case of each recursive call, let's assign it to a variable like prev, const prev equal to reverse linked list with head.next. So if we are not fall into our base case, and also if we are out of our recursive call, it would mean that we are currently on the way back from base case, stepping up one by one in our call stack. So we need to do two things here. First, make the node that we just visited to point to the current node. Second, set our current head in our call stack to point to null, because it will act as a temporary end node for our reverse linked list. So first we will do head.next equal to head, then change head.next instead of pointing to node that we just came in to point to null, head.next to null. At the end, we will return our prev variable, which still holds the entry point for our reverse linked list. So we will do return prev, but we have one small bug here. Remember that our last example was an empty linked list. Just think about what would happen if we pass null as head. It will immediately throw us an error, right? Because null is not pointing to next in this check here, and we are not checking for that. So we need a guard for that as well in the beginning of our algorithm. So we will do if head equal to null or head.next equal to null, return head. So if we run this, test cases are passing, and if we submit, we are in a good shape and everything is fine. For time complexity, we will have O of n, where n is the length of our nodes in the linked list, because of course we are traversing all of the nodes. For space complexity, it also will be O of n, because we are using call stack, and each call stack step requires to being tracked in memory. Basically, one call stack for each node in linked list, since we are going as D path to reach our base case, which is the end of linked list. And with that, I can say that was it for this video. For iterative solution, you can check another video that I have in channel. I'll put the link in the description, and also make sure to check the linked list playlist as well. So please like, comment, subscribe to the channel, and finally hope you enjoyed this video and stay tuned for next one.